All right, in this Will It Run video, we got an old Saxon motor car company engine. It's probably about a 1915-ish. I have no idea when the last time it ran, or if that was even while it was in a vehicle. But I picked this up on Facebook Marketplace just to thought it was a neat looking engine. Just wanted to see it run, see if we could figure it out. Let's do a quick walk around. So we're missing the front pulley and the fan. Not a big deal there. Notice there's no water pump on this one. So this one's a thermal siphon set up. There's a serial number. Online, I've seen some of these tags in brass, so I'm guessing this is a later one. I believe they stayed in production up until about 2022, if I remember correctly. So on this side, somebody has obviously replaced this with a piece of pipe. On the pictures I've seen of the originals, it is not a piece of pipe. This is a little iffy to me. I do not think this starter setup is original at all. The few pictures I could find with the original starter setup, it looks more like it's gear or chain driven from the back. And there's a starter and then generator mounted together. On the ones I've seen, there is no ring gear. This one actually looks like it was welded in place. The starter has this bracket welded, and when we remove the starter in a little bit, we'll see how this whole assembly is welded in place. So that's a little iffy. On the back side, looks like the original flywheel to me, other than the ring gear. Got some spacers here. Somebody's messed with some screws. This used to have a multi-disc, multi-plate clutch on it. The distributor's interesting. This is actually not the distributor that came on it, from what I can tell, doing a little research on these things. The original distributor was made out of pot metal. It would rot away, and there's not many of them around. This one, I've actually, through tons of searching on old pictures, this one to me, I think, is a late 20s Chevrolet 4-cylinder. And they did some modifications here. They machined this housing down and even machined the teeth off the gear so it could all fit through here. And another thing I noticed, this piece that engages the drive down here looks like it's semi-homemade, and then that looks to me like some kind of brass bushing, like a wrist pin bushing or something. They pressed in place so it would hold it centered. So that's kind of neat. I do have parts for this. I found a cap and points and everything online, so I got that handy. This little gearbox here is made out of pot metal too, and they're almost non-existent. I am worried about just running it. I do want to take this off and hope it doesn't fall apart. I mean, we got a little slack here, but I don't want to run it and tear that up. So I want to try to open it up and maybe take some measurements off of it in case I need to make something. But mainly I want to get some grease in there. Unless there's another way I can find to pour some oil down in it before the test run. But eventually I want to restore this, so I don't want to tear it up too bad. Now here's the oil pump. It's got a front and rear main bearing. This part goes back to the rear main bearing. And the other looks like it sprays the timing gears there. Maybe there's a passageway going to the front main bearing in this. I would imagine so. Or a cup there that catches the oil. I'm not sure. Here's the fill port. We're pretty clean inside. Carburetor is a Mayer Model L Now, I did do a little bit of tinkering with this carburetor. It had a repair where this screw would not seat, the adjustment screw, and it would not close off the jet. It was not a very good repair. It wasn't soldered on straight, so I actually was able to desolder this and fix it correctly. So I'll show you some pictures of that really quick. Okay. Now, I did not clean this carburetor up other than doing that repair, so we still need to take this apart and clean it enough to make it work. But back down to the front half. Now, all this oil on top was me being stupid. I was squirting oil into the cylinders with a squeeze bottle and squeezed it a little too hard. The cap blew off of it, and it covered this and covered the side of my tractor. So this was dry as a bone, no oil anywhere. But after putting some oil in the cylinders, I ignore that. That's the loose starter in the way there. It spins over nice. So I've noticed something. Just checking compression, turning this over by hand. Hold my finger over the spark plug. Got a little bit here in number 1. Number 2 is really good. Number 3 is really good. Number 4, I get nothing. I feel nothing there. So maybe a valve's hung open. And we'll take this little side cover off. There's only 2 bolts to look at that and see if any of the valves are stuck open. I'm hoping I don't have to remove the head. I don't want to remove the head for the test run. I want to just make it work. So here's the plan. Take the distributor apart, clean the distributor. Take the distributor and clean it up. I'm not going to do a full cleanup. I'm just going to clean up what I need to make it work. I want to figure out how to lube this gearbox. If I can get some oil through a passageway there, I'll just oil it up that way. If I cannot, I'm going to try to take it apart, but I am afraid it's going to grenade if I take it apart. And the other thing I want to do is I want to take the oil pump off and make sure the oil pump works, because I'm sure this thing is very dry. And I'll also pre-lube all these ports, pump some oil through it. So anyway, that is the plan. There is another thing on the bottom we can't really see until I put it in the air, but it was set down in the oil pan so much the oil drain bung is broke off and pushed up in the engine, so we'll have to weld that up. But all in all, I think we can make it run. So first step, let's pull that carburetor off and take a look at it. Well, this part's easy. It's only on there finger tight. I just threw it back on there for the beginning. Yep. Alright. Let's get a closer look. Alright, here we go. I'll show you this repair a little closer here in a second, but let's go ahead and open it up. Take the top half off first. When I got it, it was missing these screws and it really wasn't connected. But luckily all the parts were still there. I'm sure this didn't have Phillips originally, but it's what I had. So I just wanted to put it together for that intro essentially. Okay. So we'll talk about the top part in a second. Let's wait on that. Let's go ahead and take the flow bowl open. First take the bottom off. That's not supposed to come right out, but I'll show you that in a minute. Okay, so the way the float pole works here, and it's in okay shape. There's a piece broken here, one of the metal clips, but I can make it work without that. This is your float valve. Fuel goes in here, and this pin, when it pulls up, it closes off fuel flow. When it goes down, float goes down. It lets it flow in. This goes through here. Actually sticks up, but I'm not going to worry about that right now. And the float rises once it fills with fuel. So that's essentially how that part works. There's a little hole in the back there, or bottom I should say, that leads across to this needle. And here's where I'll show you some stuff here. So the repair on this before, you saw the picture where it was all boogered up with a ton of solder. I thought it was actually brazed on there, and I was looking for a carburetor. Then I thought maybe I'll just mill that all flat and start over and put my own chunk of metal there, solder it up and drill it and everything. But once I just did some cleanup, hit it with a sandblaster real quick, I realized, wait a minute, this is solder. So I desoldered the whole thing. Heated up with a torch, wire brushed all the solder off. This piece here is actually brass. It's not original. Somebody made it, and it had a little shoulder on there where it was press fit. Well, not real press fit, but you could press it in and it would stay. So it really didn't need all that solder that was gobbed up around it. So I just filled the cracks with solder, and it works pretty good. I have broke it since then, but I made a tool to center it because it actually goes into this jet. I machined this screw down, and it was about 1/4 inch long. But this would screw in, and that 1/4 inch piece would center it in the jet and hold it in place. And then I soldered it up, took the screw out, and pretty much good to go. Now the original original adjustment screw had a little 90-degree piece on here where you would turn it. It was really messed up. I could not get it straight. I was trying doing it by hand, but with that 90-degree piece on there, I could not get it straight enough. So I cut that off and chucked it in a lathe and recut the tip of this and polished it up. So I tighten this down in there, even just finger tight with nothing to turn. It seals completely now. So that should work good. Let's see. There's supposed to be some packing material in this piece to keep it from leaking fuel, because if that leaks, it's going to drip fuel the whole time out of the float bowl. Now, once you adjust this, that needle plugs this jet right here. And I'll show you a little exploded diagram of this in just a minute. I think I was looking for something to make a quick handle on this. I think I'm going to solder this in place right there. This will be my adjustment screw. I don't know. We'll play that by ear. So on the front here, there's a choke. Feels like it has a little spring and detent ball in here that holds it in place. It's kind of good. I'm guessing this tightened down over an air filter or air intake tube of some type. On this top half, we have this section, which is like a venturi. So it's going to pull air into here, into this venturi, and draw fuel up through this tube, and then go into the engine. And that's this. So this screw is adjusting the fuel for that. And then there is this secondary piece here. So this sits here, and this is, I'm not sure what you would actually call this piece, but it's a valve that opens up under the vacuum. So if you open the throttle pretty high, it's going to pull this up and draw in more air. Unfortunately, it'll draw all the fuel it draws is through that, so I'm not sure how that will work out. We'll play with it and see. It is also adjustable, so there is linkage here to adjust how far this valve can open. But there's really not much cleaning that's going to have to go on. There's a screen inside of here, which is odd in my opinion. I don't know if you could see it very well. Yeah, it doesn't really show up very good like that. It needs to be cleaned out, but it's not bad. I will need to straighten this throttle arm. It won't go back to idle. The passageways, though, I've cleaned while I was doing this. So the hole here leading up. So that won't be too big a deal. So I'm going to clean this all up. And then put it back together. It won't really be much cleaning going on for the most part. I'm just going to clean out that screen, actually. I'll clean out that screen and put it back together. If I restore this engine like I plan to, I'll do a whole video on taking this apart, cleaning it and everything, but I won't necessarily video that part because there's not really much to it. But let me show you the layout of this carburetor real quick. So your fuel enter's here. That's your fuel valve, your float. When the fuel goes in and fills up this float, float rises, closes off our fuel inlet. Where the fuel from the float bowl goes into the carburetor, it goes down. Let's see, we'll put this the same way here. Goes down this section right here. And you have this adjustment screw, which adjusts the amount of fuel that goes through this tube that sticks out of the top. This piece right here is your venturi. So when it's pulling air in, it's going to draw a slight vacuum in this area and draw fuel in. And the fuel is going to go up and into the engine. And this section right here is this valve. Once you open the throttle higher, it's going to open this valve. So it's going to bypass the venturi and draw more air in. So maybe this is something you adjust rich at idle and it leans out when you open the throttle. I don't know, but there doesn't seem to be a way for it to bring in more fuel when it adds more air. So we'll play it by ear, but see how it goes. But this is the layout for this thing. So I'm going to go ahead and clean this up. Just clean that screen and put it back together. And straighten this arm, and that'll be it. That's all I'm going to do to this. I won't bolt it back on now. We've got some other stuff we're going to do with that motor first, but we'll go from there. Alright, next up, let's pop this starter off and take a look at it. So there was 2 bolts here. I've already taken those off. The way this mounts down, you can see that's welded in place there. This bolts to the back retainer for the rear main seal, or whatever that is back there. As you can tell, this part's home built. If you look right here, there are normally 2 pieces that are cast out here that bolts go into. Looks like those were ground off or cut off with a cutting torch. Then welded the strap in between. And this bar up here, it looks like they screwed in bolts, cut the bolts off, and then welded that bar to the bolts. And then made this. It locks down. It's kind of neat the way it sits right and lines up with this. But yeah, that ring gear is definitely welded on and not great. So I'm not sure what this starter is originally off of, but I do know that it is seized up, so we need to free it up and get it working again. So let's go ahead and do that real quick. So this looks like a Wagner Type S-462. Wagner Electric Corporation, St. Louis, USA. See if anything alive comes out of there. Brushes don't look bad. Commutator looks pretty crusty. Well, dirty, not really chewed up or anything. That's a awesome weld right there. So originally this motor had a hand start option, but the front pulley's not even on it, so I don't have any of that. Alright, so this starter itself I have not applied power to and tried, but I have tried to turn it, and I can't. It does not spin, and this is pretty nasty, so I need to open it up, free the bearings, clean the commutator, then put it back together. That's the plan. I would imagine this is a 6-volt starter. It doesn't say on that tag what voltage it is. Normally I'd say it's okay to run 12 volts on it, but since this is kind of rigged up, I don't know how it engages that gear. That extra speed might tear up the ring gear. I don't know. I'm sure we'll try it that way and see. Well, I'll tell you what, I hope that's not a sign. Well, no, it looks like part of it. This back piece right here is welded on. Maybe it's supposed to be. Also, looking back here, this is mangled up. You can tell somebody's been hitting it with a hammer. It's got a few cracks. That is the oil hole for it. But unfortunately, with the way it was mounted, that's aiming down. We'll see what we could do here. Held on by this nut and a little flathead screw. You know, if I walked over there and grabbed a socket, this would be a lot quicker. Okay, couple insulators. And that screw apparently doesn't hold this, it just centers it. Okay. It's not too horrible. So, kind of what you would expect here. Cast iron with a bushing. Fit pretty good. Just greasy. This part will be easy enough to clean up. Oh, that's the bearing the armature stuck in. I don't want to hit it hard enough to mangle this up. Might end up going to get the brass. No, it's not moving. All else fails, put some WD-40 in there, see if it'll help us at all or just leak out everywhere. I'm going to go ahead and take this Bendix off the front, and then I can maybe do a little more trying to twist it. I might put this back in. Use that to try to turn it. Why didn't I do that in the first place? Alright. So I might be able to turn there. I might need to clamp this in the vise. I don't know. Let's see if our WD-40 did anything. It did not seem to. Alright, let me take all this off camera and beat it up some. Okay, well that was a pain. It was stiff and hard to get out of there the entire time. So I clamped it in a vise, rocked it back and forth, added WD-40, and it was stiff the entire time. WD-40 didn't seem to help at all. I started thinking maybe the bushing in there was coming out with it, but it doesn't look that way. Clean this off. Well, that looks really good. Probably mark there, but not a biggie. But all in all, that's not bad. Brushes look okay. Pretty nasty in there. Let's see if I can get this brush assembly out easy enough. So it looks like we have one of the wires going to the field coils here. So let me remove that one. All right. And the other one should be on the other side. That one needed a smaller screwdriver. Okay. Got this up here that holds the brush plate. And I think that is it. Although I don't know if there's going to be enough room because it needs to clear this stud. Let's see, maybe if I bend that out a tad. This is a pain. Holy cow, there it goes. I don't need to run a tap over that. Okay, I'm gonna go get this thing soaked, degrease this real quick. Got some oven cleaner that works real well for this type of stuff. Alright, spray some oven cleaner on it, let it sit a little bit, then put it back together. Alright, so I'm going to degrease this a little bit. Clean the armature up some. Got the brushes cleaned up. Just sprayed them with oven cleaner and washed it off after 5 minutes. Appendix, nice and smooth. I just put it in the wire wheel. Cleaned up both sides. Still need to tighten up this bolt, but I'll wait till I'm on it. This was interesting. So this pot metal is the bearing. And I'm starting to wonder if it was poured in place or something like Babbitt. It almost looks like it. Doesn't look like it on the inside, but it almost looks like it on the outside, but maybe not. Maybe it's just pressed in and crimped over. This material has changed shape so much it fit pretty tight, even after it was perfectly clean. So I took a small cylinder hone and honed it out a little bit. And now it fits great. There was like a freeze plug I guess not really freeze plug. There was a plug on the back that popped out while I was cleaning it, but no biggie there. The armature cleaned up a little bit. It's good to go. And the nose of the starter, I just cleaned that bushing. So now the trick is get this back in. Maybe. Oop. Actually, there's a couple other things that need to happen first. So I can put this in later. That goes there, not a biggie. I think there was 2 of these on here. 2 insulators. I don't think that goes on anything else. No, the smaller one went over that. These fell off as I was taking it out. So I think there was 2 insulators on this bigger one. Just in case that piece right there breaks. I'm going to make another one real quick. Just out of some gasket material, temporary stuff. I don't even care how perfect it is. Okay, so I'm going to put down this first one. And let the second one hold it in place. That's a little bit too big diameter. So, and these are just little scraps I had laying around. That's why they're this shape. It was a hole out of some other gasket. Look at that perfectly not round thing. Okay. Good enough. This other one probably just fall out. So I'll tell you what. Let me try to put it in and see what it does. So that goes over. One might keep it there. The other one we'll have to put in after. Wow. Okay, we're in. So let me get this other insulator where it's supposed to be. The screw actually goes through that one. You know, I'm not even going to put this back cover on. And I'm going to bolt it down like this. Alright, so it's got adjustable timing. All else fails, set it in the middle. Okay. Plate looks level, so the spacers on this side match that side. Put a couple screws in here. Alright, so if I like everything else on this motor. If I end up restoring it, I'll have much better videos and we'll clean this up and make it look brand new. But for this one, I just want it to work. I guess it's time to assemble the armature. A little bit of grease here. And we'll tighten up this other one. Alright, a couple problems. One, when I bent this back, it's about to break off. There's no way it's going to fold back without breaking, so we're going to get rid of that for now. Since this is just a will it run, it won't matter. It's not going to have time to work its way loose, but if I rebuild this, I'll definitely need to do it better. And I'm going to put a couple washers there so I could actually tighten the spring down and it won't hit the shaft. That's my plan anyway. Okay, it's tight. It still works. Good to go. Alright, armature's done. Let's see if we can get some grease in this bearing. Alright, we're going to put it on this end. This way there's constant pressure. You can't see anything I'm doing, but just a little bit of grease on the front. You know what? Maybe I will cover this and put the cover on. That way I won't, at least I won't start a fire or something if there's a ton of sparks and I got gas somewhere. No telling how this thing is going to act. Here we go. I'll put the band on it after we test it. Alright. Alright, will it work? It's going to work or spark a lot, I guess. That's good. Bendix works like it should. Oh. The power jumper box drew too much current there. Alright, one more time. I'm happy with that. Alright, starter's down. What's next? I think next up we should remove the oil pump. Looks like these lines are soldered in. I don't know if this T threads in or not. Probably does. I doubt they would solder it to steel. Alright. All the red paint on here. I wonder if the red paint's original. It looks like it probably is. Alright, so it's probably the pickup tube from the bottom. Plunger style. The plunger's got some wear in it from the cam. Apparently it hasn't been rotating. Cam feels like it's decent. Well, dry. So maybe there's a check valve in there. I doubt the check valve's in the pickup. I'm going to clean this off and we'll check it out, see what it looks like. Alright. See if I can get a light going. Quick peek inside. It feels good. Cam lobes in there even look good. I'm glad to see there was a number 4 piston or connecting rod, because I was wondering, with zero compression, I didn't even feel any wind coming out of that. Alright, let's take a look at the pump. Okay, my workbench is becoming quite the mess here, but let's take a look at this. So the plunger itself looks decent, except for this. It's not very deep. I'd probably chuck it in the lathe, peel it off a little and polish it. Might be hardened, I might have to grind it. Yeah, I'm sure it's hardened, although not too good. Or maybe it was just a lack of oil getting to it. Fit in here, there's not much play. Alright, so I put this in a vise and broke it loose. I have not opened it up yet. When I shake it, I do hear something rattling in there, so I'm sure the check valve's there. It does not come out. Looks like inside of there might be a pin. Pin going across there. And looking at it, it looks like it's a brass or copper ball. And just plugs it based on gravity. Get some compressed air blow through there, see what it does. Yeah, there's hardly anything. I barely feel any pressure building. This path should blow clear. All right. Okay, I did this off the bench the first time to blow through here. Just make sure we're good. All right, oil pump seems nice. Let's take a look at the oil pickup. I'm gonna blow air through it and see what it does. Blows free, so that's good. See what this other one does. Blows in the crankcase freely. That one flows freely also. Okay, that's good. Need to do the distributor, but we'll wait on that. I think I want to pull the oil pan and see if I can fix that bung. My welder is broken, so I won't be able to weld it back in place, but for this, I'm sure I can figure out some way to plug it. So next step, I'm going to get this in the air and we'll pull the oil pan off and see what we got to fix that, and it'll give us a chance to look up in there and see what shape the bearings are in. See you then. Little update on the pump here. So I cleaned it up, polished the inside of this a little bit. Cleaned this till it was pretty smooth. This is the biggie. I machined down that surface. So should be good to go for another 100,000 miles, right? So check valve works pretty good. So if I plug this hole here, it's hard to pull out. The check valve's holding pressure. If I unplug that, obviously it falls right out. So that's good news. All right. Making a mess. Should have known that was going to happen. You know what? It feels like there's a check valve here too. I did not realize that. Because if I press this like this and I was holding the end, you should get everything coming out of that. But it actually builds pressure. Hold my finger on this. That actually builds vacuum and holds it. That's interesting. Well, I don't know where that... Oh, I bet this check valve is in place once you remove that pin that crosses there. And maybe it unscrews, I don't know. I'm not going to mess with it, don't want to break it, but once you remove this pin and this check valve, maybe you can go down and get access to this one. Alright, it's nice to know there's two of them. It'll hold prime a lot better that way. Yeah, it's a pump. It's working. Now we'll move on to put the engine in the air and pull the pan off. Well, here it is on the ground. Seemed like it was just easier to throw it on the flywheel. There's enough mass to keep it there. I got a board behind it to keep it from flipping over the other way anyway. But we'll pull the oil pan off and see what we got.